AC circuit. A circuit consists of a resistor of 500 ohms and a capacitor of 5 microfarad connected in series. If an alternating voltage of 10 volt and frequency of 50 Hz is applied across the series circuit, calculate the reactance of the capacitor, the current flowing in the circuit, the voltage across the capacitor. If the capacitor is replaced with an inductor of 150 millihenry, calculate the impedance and the voltage across the inductor. This is RC circuit, a circuit that consists of a capacitor and resistor. Here we have a resistor connected in series with a capacitor, and this connection is alternating voltage is applied. The resistor is 500 ohms. The capacitance of the capacitor is 5 microfarad. The root mean square voltage source is 10 volt root mean square. The frequency is 50 Hz. The information in this question, we have the resistance, which is given as 500 ohms. Capacitance of the capacitor is 5 microfarad. We have to convert this to the SI unit. That is 5 times 10 to the power minus 6 farad. Root mean square voltage of the source is 10 volts. Frequency 50 Hz. The reactance of the capacitor can be obtained from the expression that Xc is 1 all over 2 pi frequency times the capacitance, and this we can substitute the value. 2 pi being taken as 3.14, frequency is 50. The capacitance of the capacitor, that is 5 times 10 raised to the power minus 6. The whole of that expression will give us 637 ohms as the capacitive reactance of the capacitor. Then for us to find the current flowing in the circuit, we have to find the impedance of the circuit. Impedance is the square root of L squared, resistor squared, and Xc squared, capacitive reactance of the capacitor. We put in the value that we have 500 square plus 637 square. The impedance will give us, finding that is 810 ohm. Now that we know the impedance, we can find the current flowing in the circuit. The current is the root mean square current. The root mean square current will be equal to the root mean square voltage all over the impedance. That is 10 all over 810. So the root mean square current will be approximately 0.01 ampere. Getting the root mean square current, we can get the voltage across the capacitor. The voltage across the capacitor, Vc, will be given by the expression the root mean square current multiplied with the capacitive reactance. That is 0.01 as the root mean square current. Capacitive reactance is 637. The voltage across the capacitor is 6.4 volts. Question B said if the capacitor is replaced with an inductor of 150 millihenry, calculate the impedance and the voltage across the capacitor. In this situation, the inductor replaced the capacitor. Inductance is 150 millihenry. We convert that to the SI unit. 150 times 10 to the power minus 3 Henry. Inductive reactance given by the expression 2 pi frequency inductance. That is 2 pi is 3.14, frequency is 50. We have the inductance which is 150 times 10 to the power minus 3. The whole expression will give us the inductive reactance as 47.13 ohms. We can now find the impedance using the expression the square of the resistor plus the square of the inductive reactance. Put in the value 500 square plus 47.13 square that will give us the impedance of 502 ohm approximately. Then the current, we need to find the root mean square current in this situation, which is the root mean square voltage all over the impedance. 10 divided by 50.2, the root mean square current will be equal to 0.02 ampere. 0.02 ampere. Then the voltage across the inductor VL will be given by the expression root mean square current multiplied with the inductive reactance. 0.02 multiplied with 47.13. The PD across the inductor will be 0.943 volts. Let's use the same thing as writing as 943 millivolts.